Every time I use my ESR meter, I get people asking me where I got it. Well, it was a kit. I built it like 30 odd years ago. It was, I forget where it was from. It's from Australia anyway. I think it was Bob Parker maybe. Anyway, I got a new ESR LCR meter from Banggood to check out. This will measure ESR, it'll measure capacitance, it'll measure inductors, it'll measure resistance, it'll identify diodes. It does everything. It's not bad. Got one flaw, but I'll show it to you now. Check it out. Today I have another gadget to show you that I got from Banggood. This one's quite useful, actually. It's a meter, of course. It's called a QPLCR. And if you look it up, they call it a bridge tweezer, I believe is what they refer to it as. But what this is a capacitor tester with ESR capabilities. It'll also test inductors and diodes and resistors and so forth. And I have no documentation on this, so I'm kind of trying to do the translation from Chinese to English to try to figure out what it is, but I've kind of got it figured out as to what it can do here. If we press and hold the middle button, that will turn it on. And right now it's in capacitor testing mode. So if I grab a capacitor to test, it should give me both the ESR as well as the capacity of the capacitor in question. Now it doesn't test, they can't be charged, they have to be discharged. The fact that it's a tweezer means I can probably test surface mounted caps in circuit to some degree, but let's just try it on a regular cap first. So here I have three different capacitors. One is a 1 microfarad, another is a 47, I think. This is a 47. A 1, a 47, and a 330? Yeah, 330. So let's check the 1 first. So we'll just take the tweezers and we'll just put it on the capacitor here, and it says that it's 0.988 microfarads, 989 nanofarads, and the internal resistance is 11.5 ohms. Right? You see the ohms reading down there. Resistance 11.5. Let's just see what it looks like on the ESR meter and see how close it is to my other ESR meter. We'll see if it's anywhere in the same range. This one's saying 3.2. Now, this one you can change the frequency though. I've got it on 1 kilohertz. If I tap this button here and 0.3 volts, see, you can change the voltage. 0.3 or 1 volt, and you can change the frequency. I think the top button, 10 kilohertz, 100 hertz, 1 kilohertz. So if I test it with 1 volt across at 10 kilohertz, the reading is 3.1 ohms. Okay, at 10 kilohertz, which is the same that the other meter measures 3.0. But again, you can check it at 1 kilohertz, 100 hertz, 1 kilohertz, or 10. So at 100 hertz, this capacitor has 17, and now see it's measuring 1 microfarad, 17.8 ohms, 17.7 ohms is the ESR. At 1 kilohertz, 0.994, 11 ohms, and at 10 kilohertz, 0.928, but 3.08 ohms. So it's measuring up accurately. We check the second capacitor here. This one is a 47. Make sure it's discharged. We'll test it at the 10 kilohertz. And this one here is measuring 33 point. And then it switches, actually the display switches to ohms, 0.47 ohms, which is the same as it reads down here, 33.39. On the other ESR meter, we are measuring 0.37 ohms, right? So there you go, measuring the same. This other cap, let's just do it on the ESR meter first. This one here is a 400 or 330. Did I say that was a 47 or 33? It's a 47. Did it measure 33? Oh well. This one's measuring 0.02. 0.02 at 330 microfarads. 0.02, 315, and 0.02. So it's there. It's accurate. This other one here, when I measured it, it's a 47. This one measured 33, but again, a lot of this is the frequency that's dependent on too. 37, you see, it depends on the frequency that you're testing it at. And 40 at 100 hertz. Of course, the internal resistance is going to be higher at the lower frequencies, and that's just the characteristic of how ESR meters work. But this is this is a 47 microfarad. It's just a cheap cap, so different ones will obviously measure differently. This is the pulse that my other meter uses. This is the one that I built, and that's what it's using as a pulse for ESR testing. And it's about looks like about just under a kilohertz bouncing around here, but again, it's not an equal, like it's not a square wave or anything. It's just a pulse that it's using. Let's take a look at these other this other tester and see what it does, what type of waveform it throws across the cap for testing. And well, it's throwing a sine wave first of all, and that sine wave now should be at 1 kilohertz, which it is. If I change it to 10 kilohertz, there's the 10 kilohertz. And then, whoops, and then 100 hertz, which my probe just fell off here. But it's doing a sine wave. That's how it's testing. So the test results will be a little bit different for sure, because the way that it tests. And of course you can change the voltage. This is 1 volt. I can take it down to 0.3 or 1 volt. But it's doing the same thing. It's giving you an ESR measurement by passing an AC waveform through. Just this meter is doing it with a sine wave, and the one I built 30 odd years ago does it with a pulse. But we're arriving at the same results. So if we look at this, I think this is a 100 microfarad cap that I've got now, 100 at 63 volts. We'll check the ESR using the good old home-built ESR meter, and we will see that it has 0.36 ohms. And then if we go over to this one and we look at this one here, now I'm at 100 hertz now, so I'll bump this up to a kilohertz. It's showing 0.5 at 99.4 microfarads, and if I switch it to a kilohertz, now it's 0.4, right? And at 100 hertz it'll show 0.9 ohms. But this is good. So this little meter will give you an idea of how your capacitors are as far as ESR goes. I'm wondering how well it will check stuff that's in circuit. So this unit is off, and I should be able to probe some of these caps directly across them here and see what they read. If I can get in here and read it and see what they do here. This one here is a, what is this one, 330 it looks like. See if it'll measure in circuit. Now it's probably going to be off because there's other components in here as well. It's being thrown off by the other components. Oh, let's just turn the voltage up here a bit. 3.8 ohms, which I think is what I measured on the other one, which was within spec. 1.174. It measured the capacitance wrong, but again, I would expect that because the cap is in circuit. So we're not going to get a capacity measure because obviously we're going to be measuring the entire capacity of the leg. But it will give you the ESR of the cap in circuit. So you can check your ESR. This one's 0.5 ohms, right? If we look at the small display, 0.564, 0.5. Let's just see what the other one said this one was. 0.1. Again, other components in the circuit though can certainly affect that. And I was measuring it at 100 hertz. Let's try this one here. 0.1. You can see it. 0.1. There it is. It switches over to the big display. So ESR wise, it's fine. It's measuring ESR, no problem. In circuit. Anyway, I just figured I would throw that out. I think it also does, we press the middle button here. This is the power button. You press and hold to turn it on and off. See, I don't know the menu because I can't read Chinese. Apparently it's supposed to operate in English as well. I don't know what that says in Chinese, but I know if I press and hold that button, I get a menu that I can scroll down through, but it's all in Chinese, so I don't know what it does. So, but I know if I tap this button, it'll go into reading resistance, so you can measure resistors. You tap it again, it's going to measure capacitance as opposed to being an auto, and I believe this is diode test mode, and then back to auto. I think that probably says auto, that probably says resistance, and that one is capacitance. That's resistance, I'm sure, and that one is resistance. I can't read it. I know that's resistance. Okay, starts out in auto. That might be voltage drop. No, that's inductor. Okay, that's for measuring an inductor. Microhenry. Let me grab an inductor because it does induction as well. Let me go grab an inductor and we'll measure that. This is a 10 microhenry. And my fingers are probably affecting this because I'm touching it. Can I do this without touching it? According to this, is measuring 7.8 microhenries. And this is supposedly a 10, according to the color codes: brown, black, black. But it also has a silver, which is what, 10% tolerance? Measuring about 8 on the meter, 8 microhenries. Get you in the ballpark. We'll measure resistors here. I don't know what mode I'm in. Okay, that's mega ohms there. Nanofarads. That's microhenry, because if I short it together, it tells me what it is. That's probably continuity or a diode test. Don't know what that one is. That's ohms. Okay, so this is a 3.3K. Orange, orange, red. 3.3K. There you go. 3.3K ohms. That works. This one here is a looks like blue, red, yellow. 650K. And it's probably off because these old resistors were not very accurate. But it says 655K because I don't trust some of these old resistors. So this is showing 650, right? 0.658 meg, 650, 658, 650, 656.6. It's accurate. This resistor is not, and that's the problem with the old resistors, right? Should also do diode test too. I don't know which mode that is. It's one of these modes. It might be this one. I think it might be that one there. No, that's microhenry. It'd be this one here probably. This is a PNP, so I don't know which is which on this. It says it does diodes, but we should get if this transistor is any bloody good. I don't know if it's any good. This might be continuity. It says it can do diodes. It beeps. I don't see anything emitter to base either direction, so, but it does say it does do diodes, so maybe it's just oh, that's the diode mode. I just saw a diode flash up there for a sec. Yeah, diode. Okay, it's telling me the direction of the diode right there. Right, I got a diode. Oh, look at that! It tells me the polarity. So it says, yeah, that's a diode. Look, see. Cathode's on the top there. Now it's on the bottom. So you can test transistors between base and collector. It'll tell you if it's good. And if I go between emitter and collector, it should say, oh, it's even measuring that. You can even measure the junction through that Maybe this transistor is no bloody good. That wouldn't surprise me. Not a transistor tester, it's a diode tester. But it tells you, if you've got a diode, it tells you what way the diode is. So on this one here, this is a PNP. So I should have... Oh, this is bad. Oh, you know what? This is a germanium. A 2N268. This is a germanium transistor, not a silicon. I just grabbed whatever was in the bin, right? Okay, here's a proper NPN. Right, 0.5 volt drop. This is a standard silicon. And on this guy, you see nothing between emitter and collector. Emitter and base, it shows. Note the voltage drop at the bottom of the display. Conduction one direction here between emitter and, or between base and collector and base and emitter. We've got conduction, and between the collector and the emitter we've got none. So that's measuring the two diodes. There's one. If I turn it around, it'll go the other way. You see, it doesn't care. It measures either way. That's kind of cool. But so you can get a go no go on transistors between measuring the base and the collector and the base and the emitter, and you'll see it show up. And between the emitter and collector, nothing. That's kind of cool. It'd be nice if I could get this into English, but I haven't figured it out yet. I went to the website, and the manual, it says it's bilingual, but I don't know which one of these. I don't know which one of these options here. You can scroll down through them. I don't know which one changes it. It's not nothing's in English. You can go up and down through them, but I don't know which one or what it's changing. Oh, that changes the background color. What does this one change? Oh, that's changing what it starts at. 1 mega ohm, 10 mega ohm. That's for obviously for resistance measurements. Auto. I guess that's, whoops, I guess that one's auto. Uh-oh. Now I may have screwed it up. Okay, it's back to auto. Back to capacitor when it starts. Oh well. Just want to quickly show you this. I think this could be a very useful tool, and it has a rechargeable battery. You just plug it into USB and it charges up. This could be a very useful tool, not that expensive, and it does measure ESR. So just that alone, the fact that you can measure capacitors and measure your ESR, might make this one a useful tool to have, and I'm going to keep it on the bench and we'll try it out. Seems to do the job okay. Measures caps, measures inductors, and you can use it to measure other things as well. But something like this, I think anyone who buys one of these is going to be using it for one thing and one thing only, and that's checking the ESR of capacitors. That's that, and measuring coils and so forth. But diode test, it'll do it. Big deal. You got a meter for that already. Same with measuring volts and ohms. You've got a meter for that already. Capacitors, good addition to have. Link is in the description. Thanks for watching.